So here's a look at number 33 from section 3.6. Now, what they want you to remember is that we have a couple different versions of the chain rule, and one of them is that like dy dx is equal to dy, let's say du times du dx. That's one way of looking at the chain rule. But there's an alternate way that we're going to look at specifically for this problem, and that is f of g of x. If we want to take its derivative, it can be thought of as the outside derivative leaving the inside the same. And my board's out of calibration, so I can't even write on that part of the board. Hold on. I hate doing this. Don't! All right. That it's outside derivative, leave the inside the same, times the inside derivative. Okay? This function, this notation here, is equivalent to f of g of x. These two are equivalent notations. So what they really want you to do is say, hey, this is going to be f prime, leaving g the same, times g prime. The other way of thinking of chain rule. Okay? So what is f prime? F prime is 5u to the fourth. What is g prime? G prime is 1/2. Okay, I have left the inside the same. U is g. U is g. So I have left the inside the same. Times 1/2 x to the negative 1/2. Okay. Actually, I'm gonna change my notation a little bit. I'm gonna get rid of that when line.
Thank you, Mr. Baker. Is that negative 1/2?
Is it negative 1/2?
Yeah.
Okay.
Okay, so when you leave the
Okay.
that's leaving the g of x.
Okay. Are you okay with that idea?
Yeah.
All right. So I've taken the derivative of f, left g the same because g is u, and there's my derivative of g.
Okay.
All right.
So then plug it back in.
Okay. Now I got one other comment to make. I'm interested in what's going on when x is 1, and that's easy to deal with. I can just put this 1 wherever there's an x. But what about u? Well, when x is 1, I get the square root of 1. Oh, wait, that means u is 1 as well. So finding the derivative of the composite function when x is 1 means also finding it when u is 1. And I get 5, 1 to the fourth times 1/2, 1 to the negative 1/2 power. And that is equal to
5 minus 1/2.
well, I got 5 halves. This
Oh,
is
that's times.
this is 1. Yeah, these are multiplied. This is 1, and that's 1. I get 5 halves. Okay, let's do the same strategy for 35.
Okay.
All right, let's do the same strategy for 35. All right. So in 35, I've got f of u is cotangent of pi u over 10. I've got u, which is g of x, is equal to 5 root x. And I'm interested in what's going on when x is equal to 1. So, what is the derivative of the composite function? It's going to be f prime of g of x times g prime of x. F prime, so I need the derivative of cotangent. Co means it's going to be negative. Cotangent is going to be cosecant squared of and I need it if I'm
Oh, 1 over, or no, 5 over 2 squared x. Wait.
Wait, I'm taking the derivative of that. So outside, leave the inside the same. Chain rule. There's an additional 10 pi times 10 multiplier. And now I'm going to multiply it by g prime. G prime is going to be 5 times 1/2 x to the negative 1/2 power.
Wait, I kind of don't get why you multiply by 10.
Because this is the inside of that function.
Yeah.
So derivative of the outside, leave the inside the same, derivative of the inside.
Why are we moving? No, it's the g of x.
This is g prime of x right here. All right? So after we got all to there, now I can ask the question, what is the derivative of this when x equals 1? Oh wait, I got to ask the other question. When x is equal to 1, what's u equal to? G of 1 is equal to 5 times root 1, which is equal to 5. So this is saying, what is this value when x is 1 and u is 5? So what do we get? Negative cosecant squared of pi times 5 over 10 times pi over 10 times 5/2 times 1 to the negative 1/2 power. Negative of cosecant squared of pi over 2 times pi over 10 times 5/2. Let's see. Negative. What is the cosecant of pi over 2? Cosecant is 1 over sine. So what's sine's value at pi over 2? I believe it's 1.
Yeah.
So this is 1. So if sine is 1, what's the reciprocal of sine? Reciprocal, not negative reciprocal, just 1 over 1. So it continues to be 1, so I got 1. So this value is 1 squared. These two, and there gives me pi over 4. My end answer is negative pi over 4. All right? All right. See ya.